For centuries, infrastructure has been silent. Pipes did not report their condition, valves did not signal fatigue, water systems did not ask for maintenance. Failure was the first sign of a problem. But a new generation of buildings is emerging, buildings that monitor themselves, diagnose their own weaknesses, and request intervention before damage occurs. This is the beginning of self-diagnosing infrastructure. Traditional plumbing is a collection of independent components. A smart water system is an ecosystem. Flow meters, pressure sensors, acoustic detectors, temperature probes, all connected. Data is no longer isolated. It is shared across the entire network. This creates a system that understands relationships, not just measurements. Self-diagnosing systems do not wait for alarms. They continuously evaluate infrastructure health. By combining pressure, stability, flow, behavior, acoustic activity, thermal patterns, the system calculates a dynamic condition index. This index shows whether the system is stable, degrading, at-risk. Maintenance becomes data-driven. When a failure risk is detected, the system can act immediately. Valves close automatically, zones are isolated, water supply is rerouted. This prevents local damage from becoming a building-wide disaster. Resilience is no longer based on manual intervention. It is embedded in the infrastructure. Instead of reacting to emergency calls, maintenance becomes scheduled by the building itself. The system predicts which component will fail, when it will fail, what intervention is required. Spare parts are ordered in advance. Work is planned during low-demand periods. The entire maintenance process becomes optimized. Self-diagnosing infrastructure is not static. It learns. Every repair, every anomaly, every operational cycle improves the prediction model. This means that over time, detection becomes faster, false alarms decrease, system efficiency increases, the building evolves. Water infrastructure does not operate in isolation. Hot water demand affects energy use. Cooling systems depend on water availability. Climate conditions influence consumption patterns. In an integrated smart building, these systems exchange data. Optimization happens at the whole building level. This creates a true cyber-physical ecosystem. When self-diagnosing buildings are connected, the impact extends beyond the property. Urban water utilities receive real-time demand and leak data. Peak loads are reduced. Water losses across the city decrease. Infrastructure planning becomes predictive. The city itself becomes a self-aware water system. The future of water infrastructure is not only smart, it is alive.